So the workshop topic is very nice. That is the 21st century design trends, challenges, future roadmap for transitioning technological generations in semiconductor. So Madam told me to talk about the semiconductor. So I selected particularly semiconductor topic and not included my research exactly, but it's a generalized topic. So the title of my presentation is Unleashing the New Era of Semiconductor. So I will start my talk with this quote: semiconductors are incredibly impactful in our life. I think everybody is will agree with this. And of course, our life is controlled by semiconductor only today. That's why it is said that semiconductors support everyday life. आणि हे अगदी सत्य आहे. मला हे म्हणायचं आहे की आधीचे पूर्वीचे लोक सकाळी उठल्यावर सूर्याला नमस्कार करायचे आणि म्हणायचे की आम्हाला दिवसभराची एनर्जी दे, सक्सेस दे, सगळं काय. पण आज प्रत्येक जण उठल्यावर काय करतो, आम्ही मोबाईल हातात घेणार आणि त्याचं चार्जिंग किती आहे ते बघणार. कारण पण तो मोबाईलला दिवसभर वापरायचा असतो. तर ऑब्वियसली बट ऑब्वियस म्हणजे त्यांची आता आपली पण काही चूक नाही. तुम्ही आम्ही सगळेजण हेच करतो. So it depends how we are implementing and using the technology up to what extent. So actually it is based on that. But this also we have to keep in mind that there are certain advantages, disadvantages also if we use it excessively. Then in terms of the memory storage devices starting from 1 kilobyte, very large in size, but nowadays we can make very huge storage using the RAM, ROM, and all sort of magnetic devices which can store the information. So, and how semiconductors are used in everyday life. So, starting with the as a restart, so we are surrounded by devices, equipment, household, all sort of appliances, semiconductor is used. So semiconductor is actually not stored as a piece of the material which you can work and complete your routine work. It is not like that. It is implemented into the device. So electrical appliances, though it is not stored directly, it is in the form, it is used in the electrical devices, electrical appliances, and we are making our life more comfortable. So digital consumer products, there are numerous consumer products, mobile phones, smartphones, cameras, television, AC, washing machine, refrigerator, LED bulb, what not. Everything is equipped with the semiconductor chip that we use our laptop or CPU which operates with the help of semiconductors. Temperature sensors which are used in air conditioner to control the temperature and all this. So all these small equipment are made of semiconductors. Even if we consider that cooking equipment also, induction gas, rice cooker, everything is controlled by the semiconductor. So semiconductor, if we say about the semiconductor, like it helps us to live comfortably, so nothing wrong with that. Yes, we are living very comfortably with our devices that is made of semiconductor. So semiconductor plays an important role in all the sectors, including our bank and the ATMs. Then we are putting the trends online with the help of communication systems, the internet, all sort of communication systems. Semiconductor plays a very, very important role. No area is untouched by the semiconductor, everything is there. Nowadays, the car, you might be observing Tesla cars, so even the smart cars are coming into the market. So if we look at the dashboard, so it is also well equipped with the number of sensors. So advanced sensors are there. In America, there is no person cleaning the car and or this car wash wala to naam kahin pe bhi Bluetooth se nahi milta hai. Within a second, you can clean your car just by pressing the button. So sensor is implemented in that device, so that will clean your car from inside as well as from outside. That is a very advanced technology, right? So again, of course, without semiconductor it is not possible. So all sort of advanced equipment we will be observing the semiconductor. Then latest concept is about this driverless car. How it is controlled? Its driving is governed by the device sensors, right? Where to turn, which side, then the obstacle is to be considered. If obstacle is there, then the path is to be changed. So how is done? So this is possible with the help of semiconductor. So this is how semiconductor is so useful. So why are semiconductors important to the entire world today? So the important facts about the semiconductor is it is influencing our lives, it is making more easier and more advanced technology we are developing, and it is involving the semiconductor only. So what is that semiconductor? So basic elemental semiconductors called as the pure semiconductors, they are in silicon and germanium, right? They are then formulated by doping it, by adding certain different materials and then forming the composite. But the basic semiconductor is silicon and germanium. And the compound can be made by using like gallium arsenide or doping it with certain other elements like gallium arsenide. Many more metals are there. Looking at the periodic table, you can make the combination, several combinations of the material and you can obtain the semiconductor properties. So you can enhance semiconductor properties by doping it, by mixing number of elements together. And nowadays, semiconductor means it is not only the elemental semiconductor, but it is in the form of compounds. Right? It is doped with certain material in order to tailor its property to engineer those properties. These semiconductors are also known as ICs, that is in the form of microchips, which are installed in the CPU of the computers. So when it is doped with certain some other material, so it will be enhancing or altering its properties altogether and giving you the novel properties. So it can be modulated, it can be redesigned. So basic semiconductor is taken and then it is modified by combining number of elements together, and in this way one can obtain the properties needed according to the requirement or applications. Next please. So if we look into the history of the semiconductor, development of the semiconductor, so 60 years ago the memory device was like this, having just 5 MB memory storage. Now in the current scenario, you are having this small pen drive and drastically increased storage capacity, and size is also reduced. Such a drastic change is observed within just 50-60 years. And vacuum tube, that time it was a vacuum tube technology, now it has been totally replaced by the semiconductor technology. Right? So room side vacuum tubes were used for electronic operation, but now it is replaced by the semiconductor, and so size also get miniaturized and properties also get enhanced. So just looking into the little bit basics of the semiconductor. So if we consider semiconductor means basic or pure or elemental semiconductor means silicon germanium. Right? So how it is possible to modify this structure? So we have to look into the core structure of that silicon. So its balancing is 4, so 4 free electrons are available and they are available for sharing with the other elements, and in this way the proper bonding is formed and hence the resultant material that will be having the enhanced properties only because of this modification into the structure, right? So balance silicon is having 14 as the atomic number, germanium, which is another elemental semiconductor, its atomic number is 32, electronic arrangement is like this. In both the semiconductor, 4 valence electrons are available, this is called as the tetravalent. And these 4 electrons are responsible for designing the new elements, or it will be forming it will be changing the energy band structure, because everything depends on the properties, depends on the energy band structure. So that is the basic of the semiconductor, right? Everybody have gone through this since we are from the engineering background, science background, so obviously we are going on this thing. So like this, like silicon, germanium also has the 4 valence electrons, and 4 electrons are available for sharing, and in this way its structure gets modified. So this is how this silicon is more, what we can say, reacting with the other elements with the help of this valence electrons. So germanium silicon are most frequently used material in the electronic industry. That is the basic material. The history about this germanium is that it is having crystalline structure. It was discovered in long back, that is 1886, and it was extracted from certain coals and from the fine dust of that zinc smelters. It is in natural form. It is available as a germanium dioxide. It is to be reduced into the germanium pure germanium. Right? So that is the extraction technology of the germanium. Similarly, in case of silicon, silicon is not observed naturally. It is in the form of silicon dioxide. And from sand we are getting that silicon dioxide, and then it is to be extracted from the sand, and hence this technology is very, very costly. That's why we have not yet, this technology is not available in India. Right? So the current government is focusing on to that. We have to develop the technology and make it easier, and if it is available in our own country, then it will be saving our the foreign exchange, and it will be boosting our economy also. That's why the current government is focusing on this. So this is how these are the 4 sources of the silicon and germanium semiconductor. So silicon, natural semiconductor, similarly germanium, but initially germanium was invented and then later on this silicon was invented. So here it was observed by, or this was first discovery was done by this well physicist John Barton in case of germanium, and Walter Bradin, who built the germanium wafers. And what they observed, when this it was forward with the help of DC source or any type of biasing, they got the magnified signal in output. And in this way, they called it as a transistor which transferred the current from low resistance region to high resistance. So in this, that is the pathway of this development of the germanium. Next. So initially it was the germanium dominated transistor, and then later on when the silicon, when they fabricated it with the help of silicon semiconductor, then it got more popularity than the germanium, because silicon sustains more temperature than the germanium, and it is more stable than the germanium, and hence silicon is more popular and more preferred for the fabrication of the solid state devices. So very interesting story about this inventor, that is the John Barton, who invented the transistor in 1947 and 1957. So he was a researcher, and he got the very good researcher, very talented researcher, and he got the Nobel Prize in Physics. He born in Madison, USA, and he was highly talented. His parents transferred him directly from third grade to junior high school, and he then completed his graduation in electrical engineering. Then he also started for his career as usual. Then after, even though he was talented, but many struggles were there in his career. After spending 3 years' time as a geophysicist with the Gulf country, which is oil company, he went to USA for his PhD in mathematical physics, and then he moved to the Shockley lab, that is the Bell lab, and he joined there as a Shockley research group. And all these 3 people work on the transistor. How how this signal can be modified and magnified, and they got the success in 1956 for inventing the transistor having three terminals, and for this work Vani got the Nobel Prize in physics in 1956. In this way, this transistor was invented, and it was nowadays a single chip, microchip of the computer. It contains millions and millions of transistors in such a small area, like 5 centimeters, 5 or 10 centimeters, that area. So that is very prestigious, and we can say very much powerful discovery in the transistor that he offered to the whole world. So Martin shared the second prize for superconductivity theory, called as the BCS theory in superconductivity, in which he explained, illustrated how normal metallic conductor becomes superconductor at low temperature. How its resistance becomes absolute zero at absolute zero kV. So that was demonstrated by this Bardeen along with Cooper and Schiffer, and for that they also shared another Nobel Prize in 1972 for the this discovery in the superconductivity in 1972. Next. So why are these chips needed? So everywhere. So obviously this single component cannot control the whole mechanism of a device and like that. So chip making is a very complex process, and it contains, since you are electronics people, so you are many more, so no need to tell much detail about this. So such a small chip contains billions of transistors and diodes, which control the operation of the circuitry. It is used for basic use is as a switch, as well as amplifier, rectifier. So all sort of functions is performed by such diodes and transistors. And it contains so many number of diodes transistor, and as it is very powerful, and it enhances the performance of the circuit. So there are various fields in which the semiconductors are used. So more prominent applications of this semiconductor and described here. In experimental physics, the semiconductors is part and parcel of that laboratory for this in order to manufacture the devices. The first important with that is that is called as the collider, large hadron collider or the particle collider, in which the particle nature, its charges, and its charge distribution of the particle type characteristics are investigated with the help of this collider circuit. Collider with a huge machinery. It is there in that form that is named as firm. Right? So this is the international firm, and 24 countries are the member of this CERN firm, where the particle study, the complete investigation of the behavior of the particle is analyzed with the help of such type of huge collider. So it is a well-known collider, and that company is CERN. The another application is the quantum computing, a very hot topic in the research. Next slide, please. Quantum computing. So this is a very hot topic, recent topic, and here the quantum computers, its working mechanism is totally based on the quantum mechanics, the quantum computing, in which the small quantum bit, that is the electron's movement or its speed, that is considered for the operation. Since the operation of the device is controlled with the help of just single spin of the electron. Right? So quantum word is used in the sense that the quantum dots. You might be knowing the meaning of the quantum dots. The nanostructured material having the dimension between 1 to 10 nanometers are treated as quantum dots. And nanostructured material is dimension less than 100 nanometers are the nanostructured material. So what is the importance of such a small size particle? So here it is observed that at such a small scale dimension, this particles, whatever it is, maybe ceramic particle, metallic particle, semiconductor particle, they change their behavior drastically, and they offer the novel property only because of the small dimension. Right? So here, for suppose a small example, optical property because of the small dimension, reduced dimension, what happens? There is a wide band gap between the energy levels. The energy level gets widened, right? So there is an absorption, photon absorption or light absorption, as well as emission properties that get altered drastically, only because of the reduction in the size. The melting temperature for the bulk material is quite high, but when we reduce the dimension of the same material to a very low value, suppose for example gold, if we take it in a bulk form, then its temperature is quite high, more than 700 degrees centigrade. But if we reduce its size, then its temperature, melting temperature is just a room temperature. You just imagine. Bulk gold is yellow in color, but the same gold material at nanoscale, quantum scale, it will be giving the red color, intense red color. Such a drastic change is observed. So that is how the properties get changed when we reduce the dimension of the part. And then everything is governed by the quantum physics or quantum mechanics, right? Because quantum nature is apparent at that scale. You are not, it is, this classical mechanics is not applicable at such a small dimension, right? So everything is because of the quantum confinement. Confinement in the sense that particles, when its dimension is of quantum size, then it is completely localized. It is not delocalized. This is not free to move, and therefore its behavior is dominated by the quantum behavior, right? And therefore this name is given quantum computing. So this is at the quantum level, the entire operation is governed at the quantum level. Your material is of quantum size and it will be offering the normal properties, right? So what is the difference between the classical computer and quantum computer? So at quantum computer level, you are getting fast performance, the speed is reduced drastically, size is reduced, and more efficiency will be reduced. So obviously it's nothing but the technical efficiency. So this is how the technology gets advanced, right? So that is about the quantum computing. Next please. Condensed matter physics. In this case, the materialistic property of that solid or liquid at low temperature and high pressure can be investigated. So semiconductor exhibiting this quantum phenomena such as quantum Hall effect. In Hall effect, we know that the external magnetic field is to be applied. Then only it will be giving the induced voltage. Where at quantum level, in quantum Hall effect, there is no need of applying the external magnetic field, right? Spin itself will be producing the magnetic field and you will be getting the Hall voltage and like that. Electron transport in nanostructure. So again, this is at the quantum level, and spintronics. So this is a very hot topic of research, that is spintronics, the newly emerging field, and it involves the manipulating the spin of the electrons for the information processing and storage. So here in this diagram it is shown that it's a single electron having the spin. That spin movement, it can be controlled. If it is controlled, right, in a proper way, then we can make it functional and we can do that work with a single electron. So this is how the concept of the quantum spintronics is something that is another branch of the quantum mechanics. Spintronics, right? So single spin is useful to control the behavior of the device. So in future, our computer will be a single electron, like single electron transistor. You might have heard SET, that is the single electron transistor, right? So if here single electron transistor means only single electron will be used to amplify the signal. Just imagine how fast the technology is, right? So all this is based on this quantum behavior of the particle. So obviously it will be using the nanostructured material, not the bulk material. And of course the base is the semiconductor material. So then finally semiconductor physics. So obviously it is useful to understand the behavior of the electrons and holes in the semiconductor, because in semiconductor devices are always bipolar devices. Current is contributed by the electrons as well as holes. So you can control both, and therefore to study the behavior of the electrons and holes. So it is related to the semiconductor physics. So it will explore probably the carrier transport phenomena, the energy structure, then the doping mechanism in the semiconductor, and then semiconductor and final device interaction. So it is leading to the theoretical and simulation part as well as the experimental part. So nowadays the trend of the research is like that directly experimentation is not done. First simulation is to be done. So from the simulation you can optimize the procedure, you can optimize the properties, you can decide in what type, in what ratio you have to combine the materials. So this is done with the help of simulation. So that is the theoretical work. And then it is to be implemented into experimental. So as to save your time also, you can save manpower, you can save your energy, and in a very small period you can get the large output. So that is the outcome of this theoretical study in research. Next, optoelectronics photonics. So here in our country nowadays it is also getting talent. Semiconductors are extensively used in optoelectronic devices like LEDs, laser diodes, photodetectors, solar cell. The new concept of the solar cell is bifacial solar cell. Right? So we know that once solar panel is implemented, the front face which is exposed to the sunlight, that will be converted to sunlight into electrical energy. But the new concept is that the back surface, this diffuse reflection from the plane surface on which it is mounted, that can also be collected and can be converted into the electrical energy. So in this way it will be adding or enhancing its power. This from the front side as well as from the back side it will be taking the power. So you will be generating the power from both sides. Right? So the bifacial solar cell is also the new concept and nowadays it is implemented. Nanotechnology, so obviously it is based on the nanostructure material whose size is less than 100 nanometer. So it can be in the form of quantum dots or 1D structure, 2D structure, 2D structure means scale. So solar cells are mostly simple. Then 1D structure, so it can be nanorods, nanowires like that. Then 3D bulk material, that is also treated as a nanostructure material. When we reinforce certain quantum dots into the bulk structure material, it becomes the nanostructure material. And we can investigate its structure, we can study its properties and so on. So ultimately it will be leading to the nanotechnology. Ultimately nanotechnology, one example of nanotechnology is atomic force microscopy. Right? To study the crystal structure surface, to study or investigate the structure of a material, atomic force microscopy, which is a characterization technique, it can be used to study the surface. What is that atomic force microscopy? You know its tip that will be resting across the surface of your material. Right? A single atom is provided on the tip of that microscope. Right? So it will be rastering or it will be covering the surface of the structure. So measuring the potential difference between the tip and the surface atom, it will be generating the graph and it will be defining the structure, whether it is smooth surface or the rough surface like that. That is the example of nanotechnology. So we can do that imagine how we try that technology. Right? So here nanotechnology is obviously based on and mostly the semiconductor material. Next. So I see that important over the past 20 years, the semiconductor technology has reduced the size, increased efficiency, speed, dependability of the electronic devices. So almost all the electronic devices are using the semiconductor material. So each feature is the crucial part and that we are created using the electronic material. Semiconductor is important. Some areas I have explained in the next slide. Semiconductor makes the life better, isn't it? Without phone you cannot do it, isn't it? You cannot communicate with anyone. If suppose say you forgot your mobile at home, you get very restless. So this one, it indicates what? You are dependent on the technology, you are dependent on the equipment, devices, right? So the devices obviously do nothing but the semiconductor devices. So it makes our life more better, convenient, comfortable, right? So the next slide. Next slide. Our future is built on semiconductors. This is also true, isn't it? Because now India is going to be a manufacturing hub. So in manufacturing hub, so what is that policy? You are increasing your manufacturing capability. You are increasing the industry, right? So what type of industry? Not the working instrument, but the smart instrument. So smart instruments require what? Semiconductor type devices, the sensors. Nowadays, every equipment is equipped with the sensors, and sensors are made up of semiconductor material, right? So where semiconductor, our future is built on semiconductor, right? So we are to be facilitated with the equipment which will be making our lives more easy and comfortable. So here it is said that we are following the Moore's law. What is the Moore's law? Newton's physics law. It says that every 2 years this number of transistor diodes will get doubled, and that will be increasing the efficiency of your whatever equipment you are designing, right? So that is Moore's law, and obviously it is followed everywhere. So our greatest potential is still it is in front of us, and it is a challenge for all of us. We have to develop the technology and take it to the 21st century. That will be leading to the development. It includes the university research on technology, that is also there. The society is there, that is called as the Semiconductor Research Corporation, and it is focusing more on this. So if we compare it with the developed countries like America, 1/5 of total revenue is annually invested in R&D sector by American semiconductor companies, one of the highest rates of any sector. Right? So this is the market findings. See why US is so developed, it is because of this. Though manpower is not there, but still technologically it is very, very strong, and we are quite behind of it. A good investment, so industrialists now, they got the vision, it's a very good investment, return will be very, very high, right? And very high scope is there for new generation also, those who want to start their startup, make the industry to become the industrialist, so one can have this choice. So this is a very good opportunity for the young generation also, like you people. Then its effect is that it will be increasing the economic growth, develop the technologies required to construct our future, as America maintain its position as the world's preeminent nation through cooperation and effective workforce. That's why it is to be rethink, new vision is to be created so that we can also follow the same path. Semiconductor can strengthen a nation, yes, obviously, right? So this is one of the new, you can say, the priorities that will be helping us to develop the nation, to increase or to strengthen the nation. National economy, this is very, very obvious and it is essentially required. Next. It improves the country's economy, and in that direction the companies are making the path forward and they are putting the efforts. So in a nutshell, semiconductor benefit our nation, it will be making our nation very strong, it will be boosting our economy, right? So there is a large this opportunities for the young generation to get engaged into such small scale industries which are based on semiconductor. Next. So finally, I would like to throw some light onto this. What is the India's mission? That is the India Semiconductor Mission. The vision of this mission is to build a vibrant semiconductor and display design and innovation ecosystem to enable India's emergence as a global hub for electronic manufacturing and design in a more structured, focused and comprehensive manner through various mechanisms. Right? Next. So while this is required, this ISL, so India ranks as the second largest importer. Remember this, this is the challenge for the young generation. We have to reduce the import of this semiconductor equipment or instrument or chips, but we have to manufacture in our country itself, right? So this challenge we have to accept, or I will request the young generation to accept this challenge and reduce the import and make the nation dependent on our own manufacturing. So recent data presented in Rajya Sabha shows a staggering 92% increase in India's sheep import over the last 3 years. Right? So we must be concerned about this also. So projections suggest India's semiconductor consumption could surpass $80 billion by 2026 and $110 billion by 2030, underscoring the urgency of balancing trade deficit. Right? So up till now we were aware about the oil import, but nowadays this import of semiconductor chips that has also become a crucial. Right? So it is equally important that requirement of the semiconductor chip. That's why we are importing it to a large extent. But now we should be we have to make a Bharat Atmanirbhar rather than increasing the import percentage. We have to decrease it and we have to make our nation more independent. Next. So, aimed at positioning India as a global semiconductor manufacturing hub, this mission transcends mere economic growth, embracing national security, technological sovereignty, and the future of the India's digital economy. So, early successes are already evident with companies. Some companies, our indigenous companies like Tata, Micron, CG, Power, receiving this approval from the ministry and making strides towards establishing chip manufacturing facilities in Gujarat and Assam. So here steps to start this semiconductor industry in our country. And it is said that by 2030, India aspires to capture 10% of the world's $1.1 trillion semiconductor market, emerging as a significant player in this pivotal sector. And let me tell you, India's rank is 66 among 130 countries globally in academia industry partnership. So we have to improve this academic industry partnership also, right? So it will be what you can say, better future, brighter future when we increase the industry academia collaboration. Just doing the research which is limited to paper, that should be discarded, and we have to take into confidence the industry. We have to have the shaking hand with the industries, increase the collaboration, and in this way we can improve our research. It should not be only for getting the promotions, for the namesake, I have published so many papers. I think this mentality, this concept, it should be avoided, and we have to focus more on the reality. So with this, I will conclude my this lecture. Thank you very much for giving me this opportunity. Thank you very much. Thank you for listening me also. Thank you.
Thank you, ma'am, for your valuable words, and really your knowledge in this field has been very much important for us. It has shown us a new path, a new light towards this semiconductor domain. So once again, thank you for being with us today.